New cars are supposed to be an upgrade, quieter, smarter, safer. So why are so many of them aging like milk? Why are owners seeing warning lights, glitches, and massive repair bills way sooner than anyone planned? This isn't bad luck. It isn't just one bad model, and it's definitely not random. Something changed inside the factories. Build times got shorter, parts got lighter, tolerances got tighter. On day one, everything feels perfect. By year 3, the clock starts winning. And here's the uncomfortable truth. Most of this is engineered into the system. The car isn't built for your decade of ownership. It's built for targets, timelines, and turnover. Once you understand the incentives behind modern cars, the whole market looks different. And once you see what's really driving these decisions, you'll understand exactly why so many new cars don't grow old, they expire. The lie on the showroom floor. Here is the factory secret no one says out loud. Most new cars are engineered to survive the warranty, not your ownership. That is the uncomfortable truth, hiding behind polished paint and LED lighting. Nearly 90% of new vehicles contain at least one major cost-driven compromise that reduces long-term durability. It is not a mistake, it is a system. Walk through a dealership and everything looks premium. Large screens glow. Doors close with carefully tuned sound insulation. Sales brochures talk about innovation, connectivity, safety. What they do not mention is how aggressively production targets have compressed build time, how material substitutions shaved grams at the expense of fatigue tolerance, or how software layers replaced mechanical redundancy. The illusion works because early ownership feels fine. Problems do not surface in the first 6 months. They surface after 30,000 miles, after 70,000 miles. After the warranty clock quietly expires. That timing is not accidental. Modern design metrics focus on predicted service life within coverage windows. Beyond that horizon, responsibility shifts to the owner. The result is a vehicle that performs brilliantly under controlled conditions, yet ages faster than its predecessor built 15 years ago. This is why a used sedan from 2005 can feel mechanically tighter than a crossover from 2025. Progress did not fail, priorities changed, and once you understand that shift, everything else begins to make sense. To see how that happened, you have to step onto the factory floor. The production line incentive. Quality does not collapse overnight. It erodes when speed becomes sacred. In modern assembly plants, throughput determines profitability. Vehicles move down the line under strict cycle times, measured in seconds. Every delay ripples outward into logistic schedules and quarterly targets. When a plant produces hundreds of thousands of units per year, shaving even 1 minute from each build saves enormous labor cost. The incentive is obvious. What is less obvious is the trade-off. Fewer pauses mean fewer opportunities for human correction. Complex wiring harnesses are installed faster. Adhesive bonding replaces slower welding processes. Modules are pre-assembled and snapped into place rather than individually tuned. The goal is not sloppiness, it is efficiency. Yet, efficiency narrows inspection margins. A loose connector may pass automated verification yet fail years later under vibration. A plastic coolant housing saves weight and installation time, yet becomes brittle after repeated heat cycles. Workers operate under pressure to maintain flow, not to overbuild for a decade beyond specification. When 90% of the industry embraces similar production tempo, durability becomes standardized around predicted lifespan rather than aspirational endurance. This is not conspiracy, it is alignment with financial models. Production philosophy no longer asks how long a vehicle can last, only how reliably it will meet forecast expectations. That subtle shift shapes every bolt and bracket. Once time is compressed, material choices follow. If this breakdown is already shifting how you see modern cars, take a second to like and subscribe so you don't miss what's coming next, and share your experience below. Have you noticed quality slipping, or is it just hype? The material trade. Open the hood of a current model and compare it to one built 2 decades ago. You will find thinner metal panels, more composite components, and extensive use of molded polymer where cast aluminum once stood. Oil pans, intake manifolds, thermostat housings. Even structural mounts increasingly rely on plastic blends designed for lightness and cost efficiency. On paper, these materials meet stress tolerances. In laboratory testing, they pass validation cycles. Over extended years of heat expansion and contraction, they age differently than metal. Adhesives now supplement welds to reduce manufacturing steps. Adhesive bonding can be strong, yet it depends on chemical stability across temperature extremes. Each substitution appears minor in isolation. Collectively, they reshape the durability curve. A turbocharged engine running higher cylinder pressure demands precise cooling. Combine that with lightweight components and tight tolerances, and the margin for neglect shrinks. Direct injection improves fuel economy, but introduces carbon accumulation risk over long intervals. Continuously variable transmissions optimize efficiency, yet rely on belts under constant tension. None of these decisions alone render a car garbage. Together, under cost and speed pressure, they reduce the resilience buffer older vehicles quietly carried. The machine still works. It simply works closer to its limits. Yet, engineering choices are only half the story. Economics complete it, built for the financial clock. The final layer of the factory secret is financial timing. Most new cars are financed for 6 or 7 years, yet warranty coverage often centers around 3 or 5. Leasing dominates urban markets, meaning many vehicles change hands before long-term weaknesses emerge. Replacement cycles, fuel growth. When reliability extends far beyond predicted ownership windows, new sales slow. Manufacturers respond by designing for projected life rather than indefinite survival. Extended warranties and subscription features provide additional revenue streams, buffering risk. The vehicle becomes part product, part platform. When a sensor fails after coverage ends, repair cost lands with the owner. When depreciation outpaces loan payoff, trade-in becomes constrained. The system does not require catastrophic failure to function. It requires only that durability aligns with accounting horizons. That is why nearly 90% of new cars feel impressive at delivery, yet reveal fragility over time. They are not assembled to collapse immediately. They are calibrated to satisfy metrics that prioritize turnover, efficiency, and managed liability. Understanding this does not demand outrage. It demands clarity. The myth of modern superiority dissolves once you see the clock governing every design choice. When cars became rolling operating systems, there was a quiet moment when cars stopped being primarily mechanical devices and started behaving like distributed computers on wheels. Infotainment systems no longer control only music and navigation. They regulate climate functions, seat adjustments, driving modes, even safety settings. A touchscreen failure can now disable core features that once relied on simple physical switches. Modern vehicles depend on a dense web of sensors measuring throttle position, steering angle, wheel speed, cabin temperature, battery health, and driver attention. All of that data flows through software layers that interpret, adjust, and recalibrate continuously. Over-the-air updates promise improvement without a service visit, yet they also introduce new code into complex systems already operating near their limits. A patch can refine performance, but it can also create unexpected interactions between modules that were never originally designed to communicate so extensively. Hardware once stood independently. Today, it waits for instruction from firmware. When hardware depends on code, reliability becomes partially dependent on invisible architecture. Glitches no longer manifest only as broken parts, but as frozen screens, delayed throttle responses, or warning lights triggered by misread data. The machine still moves, yet it increasingly behaves like a device awaiting its next update. What happens when mechanical certainty yields to software interpretation? The answer is subtle, and it unfolds gradually across millions of vehicles. And software complexity quietly raised the failure rate. From digital layers, we move deeper into the mechanical strain hiding beneath them. Complexity as a stress multiplier. Modern efficiency targets reshaped engine design in ways that appear impressive on paper. Smaller turbocharged engines now replace larger naturally aspirated ones, producing comparable power from fewer cylinders. Direct injection systems spray fuel at high pressure directly into combustion chambers, increasing efficiency and output. Continuously variable transmissions aim to keep engines operating within optimal ranges, improving fuel economy ratings. Hybrid systems blend electric motors with internal combustion components to reduce consumption further. Each innovation promises gains, yet each also introduces stress concentrations. Turbochargers raise cylinder pressure and temperature, demanding precise cooling and lubrication. Direct injection can lead to carbon buildup on intake valves, altering airflow over time. Continuously variable transmissions rely on belt or chain systems operating under constant tension, sensitive to fluid condition and thermal load. Hybrid integration adds battery management complexity and additional cooling circuits. High compression combined with tight tolerances leaves less room for neglect or variation in manufacturing. Engines, tuned aggressively, deliver performance, but the margin for long-term wear narrows. Durability testing attempts to simulate years of use, yet real-world driving patterns vary widely. Did efficiency engineering outpace durability testing? It is difficult to measure that directly, yet warranty data and repair trends suggest stress accumulation is not evenly distributed. Vehicles operate flawlessly under ideal conditions while becoming vulnerable under sustained load. And then came the most aggressive redesign of all. That redesign did not refine the existing template, it reimagined the structure entirely. The electric vehicle structural gamble. Electric vehicle architecture disrupted conventional assembly logic. Gigacasting technology allows manufacturers to produce large sections of a vehicle's frame as single pieces, rather than welding dozens of smaller components together. This reduces parts count, simplifies assembly, and accelerates production. Structural battery packs integrate energy storage directly into the chassis, turning the battery into a load-bearing element. The benefits are measurable: fewer welds, lower manufacturing complexity, improved rigidity. Yet, such integration also alters repair economics. When a battery pack forms part of the structure, damage to that area may require replacement of an entire unit, rather than localized repair. Minor collisions that would once involve panel work can lead to high replacement costs. Insurance assessments increasingly evaluate whether repair is financially viable compared to declaring a total loss. Production speed improves, weight distribution benefits, but modular repairability declines. This is not necessarily a flaw, it is a strategic choice, favoring efficiency and rigidity over incremental fixability. Are we sacrificing repairability for production speed? The answer depends on perspective. For factories, the design is elegant. For long-term owners facing collision repair, it can be daunting. Structural integration reduces complexity on the line while increasing consequence after impact. The engineering gamble reflects a new philosophy of building entire systems rather than serviceable segments. Yet design is only one dimension of resilience. Attention must also turn to the people responsible for translating blueprints into reality. The disappearing craftsmanship layer. Manufacturing once relied heavily on accumulated tacit knowledge. Skilled technicians developed an intuitive understanding of alignment, torque feel, and subtle irregularities that machines could not easily detect. Many of those workers who entered factories in the 1980s and 1990s are now approaching retirement. In their place, temporary contract labor and accelerated training programs attempt to fill gaps. Automation has replaced certain inspection layers with vision systems and torque sensors, verifying tasks that were once double-checked by experienced hands. Automated systems are precise, yet they interpret only predefined parameters. They cannot easily sense a faint vibration or detect an emerging pattern that falls outside programmed thresholds. As experienced workers exit, institutional memory thins. Companies such as Toyota and Honda once emphasized stop-the-line authority, empowering any employee to halt production if a defect appeared. That culture required confidence and deep familiarity with product behavior. High turnover environments struggle to replicate that continuity. What happens when experience leaves the floor? The production process continues, efficiency metrics remain strong, yet subtle shifts accumulate over years. The machine still meets specifications, but the buffer provided by seasoned judgment diminishes. While factories evolved technologically, the human layer changed simultaneously. And while factories evolved, the financial model evolved faster. Durability is bad for revenue. For most of the 20th century, durability was a competitive advantage. A car that lasted 200,000 miles built brand loyalty and strengthened resale values. Yet modern revenue models rely less on multi-decade ownership and more on recurring transactions. Replacement cycles have shortened. Leasing has grown dominant in many urban markets. compressing ownership windows to 3 years or less. When vehicles change hands quickly, long-term durability becomes less visible to the first driver. Manufacturers measure success in quarterly deliveries rather than 20-year survival rates. If a model sells briskly and returns to the market through certified programs, it continues generating revenue streams. Reliability remains important, but only within projected service life parameters. What if reliability slows growth? A fleet that rarely needs replacement limits new sales volume. A customer who keeps a vehicle for 15 years does not return to the showroom every 3. Growth metrics therefore align more closely with turnover than longevity. This does not imply deliberate sabotage. It reflects structural incentives. Shorter ownership windows mask aging weaknesses because many drivers never experience them. The financial logic subtly redefines success from endurance to circulation. When durability extends far beyond projected cycles, revenue velocity declines. The result is a recalibrated target. Vehicles must satisfy expectations within defined timeframes, not necessarily decades beyond. And that incentive reshaped the warranty system. Revenue alignment alone does not explain the mechanics of control, so attention turns to how protection is administered. If you want more clear, honest analysis about where the auto industry is really heading, make sure you're subscribed. We're unpacking the trends most buyers don't see until it's too late, and the next deep dive is already on the way. The warranty delay architecture. Warranties are presented as shields against defect, yet their structure reveals a layered approval process. Dealers often cannot authorize significant repairs without manufacturer confirmation. Claims require documentation, photographs, diagnostic codes, and labor estimates submitted through centralized portals. High-value electronic modules may be placed on allocation lists, limiting immediate availability. Service departments juggle repair bays filled with vehicles awaiting parts. Back-ordered components create queues that extend weeks or months, especially when global supply chains fluctuate. This is not merely inconvenience, it is a controlled financial gate. Approval chains moderate cost exposure, ensuring repairs align with policy definitions. Dealer constraints prevent independent discretion beyond certain thresholds. Bottlenecks regulate expense, distributing warranty outlays over time rather than absorbing them instantly. Why is the safety net slow by design? Because rapid, unrestricted repairs would produce unpredictable accounting volatility. Delay spreads impact across reporting periods. Meanwhile, owners continue making payments and maintaining insurance coverage. The car is technically covered, yet practically inaccessible. Warranty protection remains intact on paper, even if mobility is paused. From a balance sheet perspective, moderation protects margins. From an ownership perspective, the experience can feel suspended between assurance and frustration. Delay has accounting logic, and accounting logic often overrides immediacy. And delay has a hidden cost most buyers never calculate. Financial consequences extend beyond inconvenience, reaching directly into asset value. The depreciation trap. The moment a new vehicle leaves the lot, its market value typically declines. That initial drop can represent thousands of dollars within days. Loan durations have stretched in recent years, often extending to 6 or 7 years in response to higher purchase prices. When depreciation outpaces principal reduction, negative equity emerges. Owners owe more than the vehicle is worth, limiting flexibility to sell or trade. Electric vehicles add another dimension. Structural battery packs and specialized components can raise repair costs significantly after collision, sometimes pushing insurers toward total loss declarations for damage that once would have been repairable. The financial equation becomes stark. High upfront cost, rapid early depreciation, long loan horizon, and potential insurance recalculation. When did cars become depreciating liabilities instead of assets? Historically, certain models retained value due to mechanical simplicity and strong reputations. Today, technological obsolescence accelerates value erosion as new software features appear annually. Buyers chasing the latest updates may find previous models losing desirability quickly. Depreciation is not new, but its velocity in some segments has intensified. The mathematics affects household budgets directly. A vehicle intended as reliable transportation becomes a leveraged commitment vulnerable to market swings. While new vehicles lose value quickly, something else is rising. Against this backdrop of financial compression, a different pattern begins to emerge: the durability outliers. Amid widespread complexity, certain vehicle categories continue to emphasize mechanical conservatism. Naturally aspirated engines, free from turbocharger pressure spikes, often operate under lower stress. Traditional automatic transmissions using planetary gear sets and hydraulic controls may provide predictable longevity when maintained. Pre-consolidation era models built before major corporate acquisitions sometimes reflect earlier engineering philosophies with wider tolerance margins. Beyond domestic markets, the 25-year import rule allows enthusiasts to bring in vehicles from regions where inspection regimes and commercial durability standards shaped design choices differently. Commercial-grade builds intended for fleet service frequently prioritize longevity over novelty, using proven components refined over decades. What still works and why? Simplicity reduces variables. Lower compression ratios, fewer forced induction systems, and robust mechanical linkages minimize failure points. These vehicles may lack the latest connectivity features, yet they often deliver steady performance over extended mileage. Import communities and independent specialists increasingly recognize the value of these configurations. Rising demand for older platforms suggests a recalibration of consumer priorities. Durability outliers demonstrate that resilience has not vanished, it has become selective. Buyers willing to look beyond showroom gloss can identify machines engineered for endurance rather than feature density. But the industry sees this shift happening. How manufacturers are responding. Automakers are not blind to shifting durability perceptions. They are adjusting their strategies in real time. One of the most visible responses has been the extension of loan terms. Financing that once averaged 5 years now frequently stretches to 6 or 7, lowering monthly payments while increasing total interest collected over the life of the contract. At the same time, feature subscriptions have emerged as a new revenue layer. Heated seats, advanced navigation, remote start functions, and performance upgrades can be unlocked through monthly or annual fees. Software monetization turns hardware into a platform, ensuring that revenue continues long after the initial sale. Extended warranty products are marketed aggressively, offering peace of mind in exchange for additional upfront cost. These service contracts function as both reassurance and profit center. How do companies protect margins in a durability downturn? They diversify income streams beyond the physical lifespan of components. Instead of relying solely on repeat vehicle sales, manufacturers cultivate recurring digital payments and finance revenue. The car becomes part asset, part service portal. Buyers may perceive lower entry payments, while total financial exposure expands over time. Strategic counter moves like these do not address engineering fragility directly. They buffer its economic impact. The shift signals adaptation rather than retreat. Yet corporate adaptation operates within broader regulatory currents, shaping design complexity. And regulators are now accelerating the complexity. Industry strategy cannot be separated from policy forces reshaping vehicle architecture. Regulation versus longevity. Emission standards have tightened across multiple regions, compelling manufacturers to extract greater efficiency from smaller engines and alternative powertrains. Safety mandates require advanced driver assistance systems, including lane-keeping aids, automatic emergency braking, and blind spot monitoring. These features depend on sensor proliferation, radar units, cameras, ultrasonic detectors, and control modules woven throughout the vehicle. Compliance-driven redesign introduces layers of electronics that did not exist in earlier generations. The intent is clear: reduce environmental impact and enhance occupant protection. However, each additional system introduces integration complexity. Calibration demands increase. Replacement costs rise when sensors embedded in bumpers or windshields are damaged. Did regulation unintentionally increase fragility? It is not a question of motive, but of consequence. Stricter requirements push engineering boundaries, encouraging lighter materials and denser electronic networks. Manufacturers must balance compliance deadlines with durability validation, often within compressed development cycles. Safety improves measurably in crash statistics, yet repair economics become more intricate. Emissions gains are documented, while long-term maintenance implications unfold gradually. Regulation achieves its primary objectives, but secondary effects ripple through ownership experience. The vehicle becomes safer and cleaner, yet also more dependent on specialized calibration tools and proprietary software. These policy-driven shifts do not occur in isolation. They exert pressure on the infrastructure responsible for maintaining increasingly complex machines. And the service network is buckling under the weight. The strain is no longer theoretical. It manifests daily in workshops and service bays. The service system strain. Repair infrastructure faces mounting challenges as vehicle systems grow more sophisticated. Technician shortages are widely reported, with experienced mechanics retiring and fewer apprentices entering the trade. Modern diagnostics require familiarity with software interfaces as much as mechanical aptitude. A single malfunction may demand electronic scanning, firmware updates, and recalibration procedures that extend beyond traditional wrench work. Repair delays lengthen when specialized parts or tools are unavailable. Independent shops confront additional obstacles, including restricted access to proprietary diagnostic data and subscription-based software required to reset modules. What happens when repair infrastructure cannot keep up? Backlogs accumulate. Owners wait weeks for appointments. Insurance claims extend over longer periods. Service departments become bottlenecks rather than support networks. The mechanical simplicity that once allowed quick fixes has been replaced by layered troubleshooting requiring advanced training. Structural warning signs appear when minor issues immobilize vehicles due to sensor interdependencies. The economic burden shifts toward consumers who must navigate extended downtime and elevated labor costs. Independent operators struggle to invest in constantly evolving equipment while competing with dealer networks. The strain reflects systemic transformation rather than isolated failure. As repair ecosystems adjust unevenly, the ownership experience changes in subtle but persistent ways. And this is quietly changing buyer behavior. Shifts in repair realities are influencing decisions long before the next purchase. The consumer awakening. A gradual recalibration is unfolding among buyers who observe rising complexity and repair uncertainty. Many households are holding on to older vehicles longer, extending maintenance schedules rather than pursuing immediate replacement. Online communities share knowledge about routine upkeep, fostering a modest resurgence of do-it-yourself repair culture. Used market strength reflects renewed appreciation for proven platforms with simpler drivetrains. In my own observation, conversations about cars have shifted from excitement over features to practical questions about longevity and serviceability. The cultural narrative surrounding newness is evolving. What still resonates is reliability measured in years, not screen resolution measured in inches. A transformation in priorities does not signal decline. It signals adaptation. Consumers compare total cost of ownership more carefully, weighing subscription fees, insurance premiums, and depreciation alongside horsepower and styling. Vehicles once dismissed as outdated are reassessed for mechanical steadiness. Enthusiasts search for models built before aggressive redesign cycles, valuing consistency over novelty. This awakening is neither rebellion nor nostalgia. It is a rational response to structural change. The definition of value is being rewritten quietly in driveways and garages rather than marketing campaigns. What once symbolized progress is now evaluated through the lens of endurance, serviceability, and long-term ownership cost. The modern car is not inherently inferior. It is different in purpose and construction, optimized for speed of production and technological appeal rather than mechanical excess. This is not collapse, nor is it nostalgia speaking. It is a transformation in what new truly means, and a reminder that durability, not novelty, ultimately determines whether a machine becomes transportation or financial burden over time. If this changed how you look at new cars, you're not alone. And this is exactly why these conversations matter. The industry doesn't advertise incentives, timelines, or trade-offs. It sells shine. So if you've owned a car that aged faster than it should have, share your experience below. Hit like if this helped you see the system more clearly, and subscribe if you want more deep dives that actually protect your wallet. The next breakdown goes even deeper into what's quietly costing drivers the most, and once you see it, you won't look at ownership the same way again.